So here we can see the sun in Taurus. This is on June 1st at 7 p.m. And next one I'm going to show is 10 days later. So June 11th. And actually minus 40 minutes. That means minus 4 minutes for every day. And this is where the sun appears then, 10 days later. So it moved eastward. You see on the very right hand side written the western horizon. And so I'm going 10 days ahead just to not make it too slow. Turns out it's slow anyway because I have to manually put this in. This software that I'm using doesn't have the option of going 23 hours and 56 minutes every day, which is the sidereal day, which makes the stars appear in the same place, and so it's a little bit easier to see what happens to the sun and the planets. So yeah, so I have to always, for each day that I go forward, I have to subtract 4 minutes because the Earth's rotation is 23 hours and 56 minutes. So, and that's what's taking me so long here on the side, and I hope I'm not going to make a mistake. And yeah, we can see the sun nicely moving west to east through the constellations, because that's the apparent motion, which of course is actually our own motion through the solar system. And for the sun, it's the apparent motion. For the planets, of course, they orbit themselves, so there we can see that they also move west to east in a day-to-day motion. Yes, within a day, so within a few minutes or hours, we can always see that things are moving east to west. But if we go day to day, then we can see that truly they're actually, if we get rid, so to say, of the Earth's rotation, we can definitely see that they do move west to east. For the planets, there are two of them actually. I think you saw them moving around. Those are actually Mercury and Venus. And at some point, actually, I think you saw Mercury retrograding itself. So it's not just the outer planets that do that, but it's the inner planets as well. And it just so happens that these are the only two that I have on the screen here. Yeah, there we go. And in the meantime, I'm actually in August, and one thing, by the way, is wrong about this presentation here. You see the sun in the middle of the sky, and of course there should be no stars because it should be all bright, but I needed the stars to show you where the sun appears in which constellations and so on. I'm not ever sure. Oh, there it says actually moon. So the moon actually came by. The moon is actually so fast because I'm going 10 days at a time here that the moon really just zips through very, very fast. And again, I just have to click a lot of stuff here, changing date and time on the left-hand side. That takes a long time. And that's why this one here is so slow. In the meantime, I'm in September. Again, every time it's not exactly 10 days later, but it's 10 days minus 40 minutes, 4 minutes for each day in order to make up sidereal time. Now there the moon appears nicely. And it just happens I chose a year where only Mercury and Venus are moving through here, so the other planets are in a completely different positions. There we go. This is now the end of September. In a position of the sun, and what kind of season we have, of course, also depends on in which constellation the sun is, because then it will actually appear lower or higher in the sky. In this case, we cannot see that part because I just keep the sky exactly the same 23 hours 56 minutes later, and we can nicely see that the planets and the moon and the sun move west to east. For the sun, of course, it's in apparent motion. For the reflecting our Earth's orbit, for the planets and the moon, of course, it's their true motion. All right.